Everybody, what's up, welcome back. Today we are working on my video editor. So why are we doing this? I am streaming, I'm uploading VODs to YouTube, and as a result I'm trying to somewhat split the difference as to what is worth doing, right? So I'm aiming for 2 hours chunks because I don't think that more than 2 hours is a reasonable YouTube video. That's about the extent of what I'd be willing to watch, and other people don't exist. It's only about me, right? What I want to do is I want to try experimenting with cutting down a video into a shorter segment when I watch other stream content, not necessarily programming content, but speed running, music development, music production streams, or just general streams. You see this pattern of you do a thing live and then you cut it down and ship it on YouTube, and people are more willing to watch a 20-minute video than a 2-hour one. Great. I wanted to experiment with that, see if that works for this type of content. I'm not really sure, but when I first gave it a shot, I was like, holy crap, this is going to take forever. Cutting down a 2-hour video, maybe it's just a problem with my ability to edit, but it felt like it would take at least 4 hours to cut down 2 hours, probably more, to be honest. And so we can write code and we can solve our own problems. So something I wanted to try was, could we make a video editor that works kind of more with a script, right? So I can read a lot faster than I can scrub a video. And so if I had a script of what happened during a stream, maybe that would let me work faster. And specifically, if I could select segments of the stream and say hey, I was talking about compilation errors in this part. That's kind of fucking boring. Can we just skip that part? It would be kind of nice. So what I'm imagining is, I've got my little UI mock-up here on the right. This is me in the corner here. This is kind of the stream here. So this is me, this is the to-do, this is my terminal over here. And then I'm imagining that there's a timeline down here that I can scrub, whatever, but there's also a script where there's also an indicator of where in the stream we are. And I could maybe select text in the script and say, this is this type of thing, and I don't want that in here right now. Can we try skipping this? Then maybe, some other features you could have audio scrubbing. So if there's long segments of me going not really talking, then we could cut that out. If there's long gaps where I'm just thinking, we could cut that out. All that can be done automatically, and that should make the process much simpler, I'm hoping. So where are we at today? We have got our little sample application that opens up an OpenGL window with GLFW. He creates this OpenGL shader program that's run that presents a texture, and we are loading a picture, a PNG that I drew, this little smiley face, but we are opening it with FFmpeg. So we have all of the pieces in place to play a video if we were to just call this function multiple times. We're hoping. Maybe an am I high highlight reel. Yeah, I do say am I high a lot, and then probably a fuck. When you're sorting through compilation errors. Anyways, so we have the picture, and so today I want to see if we can start working with video. So what we have to do there is decode more than one frame. Right? We probably have to do some sanitization where we're kind of assuming things about the stream that the container that we have has one image stream in it. There's audio and stuff to deal with as well, so we have to at least make sure that we're getting a video stream probably. If I were to open this guy with Big Buck Bunny, he's gonna say, hey, the frame format's YUV420, not RGBA, so we have to deal with that. And then I'm thinking probably the next steps after that are to get some sort of seeking in place. I want to kind of, before getting into more advanced features, I kind of want to solidify the abstractions here. So if we bang out the world's shittiest progress bar with just a little blue bar at the bottom or something where you can click on the screen and then have it jump to a spot in the video, I think we'll be in a pretty good spot. We'll see if there's a good chance that either we blast through everything because it's all super easy, or there's a good chance that we get stuck on something and we don't get to the end of that. So we'll see where we get to by the end of the stream. We'll see. Okay. So since yesterday, nothing about the code really changed other than a little bit of hardening. So yesterday we had a lot of stuff just kind of like hard coded in main. I've split out this like video decoder struct that has all of the FFmpeg state for decoding a frame. And so just so that like when I run my linter, Valgrind doesn't go like, what the fuck? You allocated like 100 megs of memory and you didn't free any of it. It's like, okay, fine, dude, we'll chill. We'll free it all. Don't complain too hard, man. Then we have like this next function that basically does the like, hey, FFmpeg, could you give me the next packet? And then could we give the packet to the codec? And then could we extract the next image from that frame? Time for lib software scale. I think no. I think I'm not going to do that because I don't like the concept of it feels like it can be done on the GPU super effectively, right? You have lib software scale is like FFmpeg library that's bundled that lets you convert between different image formats, which I think is good to some extent, right? You can handle a bunch of things without writing new code. But if we are trying to write something for me and myself only, I should know what video format I'm using. I should be able to say, hey, if it's YUV 420, we can just give a YUV 420 texture to the GPU and let it figure it out. Because what you're doing is you're doing a per pixel transformation, and GPUs are really good at per pixel transformations. They do them real quick. So that's probably where we're going to end up there. So this next function, he supposedly gets a frame. Probably what makes sense here is since our pixel format isn't RGBA, we can't really test this on a video very easily. But what we could do is we could like just disable this check temporarily. And if the thing comes out as YUV 420, I think if I remember correctly, we can look, YUV 420p. I think that this means that I can treat it like black and white data. I think. Or sorry, like monochrome. So we can look up FFmpeg. Where does this thing come from? Where does this thing come from? AV pix format. Pix format. So we have AV pix format YV 420p. This one. And this says planar YUV, 12 bits per pixel, 1 CRCV per sample. And then I would look up planar YUV just to double check. Planar. Oh, here. Let's read this guy's Stack Overflow. Planar in memory is this. Right. Okay. So I think what's going on here is when we get the buffer from FFmpeg, he's kind of coming out. I guess we'll draw him like this. We will draw him like this. So this is our image, and I'm going to draw a line like this. Maybe, yeah, 2/3 of the way down. I think that makes sense. Planar C1, CR, CRC. So it's kind of like this. So in here, this is kind of like sequential memory going left to right, top to bottom. And this is like our luminance, aka Y. And this is like a, how do I say this? This is like, if you were to take this and put it in all of the RGB channels, you would get a black and white image that represents what you're streaming. Like, this is the brightness of the image. This down here is your C, B, and CR. And what is important to note here is that these are both half the size of luminance, because I think on 420 YV 420. Is it maybe, what's the Wikipedia page for this? Chroma subsampling Wikipedia. So with 420, you have for every chunk of 4 pixels in your luminance data, you have less chroma data. And that's because like we're good at like seeing edges in our brains, but we're not that good at seeing colors. So as like a video compression technique, they go like, well, we're not going to really notice if you kind of smudge the colors all over the fucking place, so we'll just write down less of them. So I don't really remember exactly what CB and CR are. If there's some formula you can use to convert between RGB and YUV, so it's something like, you know, there's just some color, something color. I don't know what they are, but I know that we can use these guys to convert into RGB. So I think the plan is later we're going to have to do some sort of like actual conversion here. But since the data is packed like this, if we just say like, fuck this shit, we don't care about it, and we just take this, then this is like essentially a black and white image and we don't have to worry about it. So what we should be able to do is just here when we load our texture to OpenGL, we say, hey, we are loading to a 2D texture. Actually, I have to look up the parameters here. GL texture text image 2D. This one. No, this one. I can't believe I got baited by an ad. So we say, hey, we want to be an RGBA texture. But the image that we're pulling from is a black and white image. Well, we can say, we technically say it's red, but red really just means white here. Because this is the way to tell it that like the image is packed as like one channel, and that channel it thinks is red, but it doesn't fucking matter. We'll figure it out later. And before we were saying here that our image stride is over 4. The stride is in bytes. So I think we just delete this over 4 here. And I think we get a black and white image here. So let's look at trying to load Big Buck Bunny again. And that does look maybe about right. So the stride is greater than the width, so we have this black section of like uninitialized zeroed out memory. And then Big Buck Bunny has like a fade at the beginning that's being shown as red right now. So let's go into our fragment shader that's running on the GPU. And right now he's saying like, hey, we got this like red image in, and I'm using it now like RGBA, but we can just say that the color or luma is a float that comes from our sampled texture at the red channel, and then we can create a new output that is red, like luma 255 1.0, I think 0 to 1 in this, I think. So now we should get something that looks like kind of like gray. Perfect. Now we have what is a lie, maybe to some extent, but we have some sort of luma thing. And so now what I'm kind of hoping is we should be able to just in our loop here get the next image. So maybe we have this like image texture. Maybe we'll change this. This takes in like a image with some like data on the CPU, and he creates a new texture, and then he uploads the image to the texture. But that's kind of like silly. Maybe we should just rename this to gen texture, make texture. I like that better. And so this will like set up our texture, which is just like an image, like just packed data that we send to the GPU. And we have like these parameters that we copied from Learn OpenGL that I don't really remember what they do. But some of these are related to like wrapping. I don't know what S and T are, but like what happens if you go out of bounds of the texture? These are saying like just fucking duplicate it, like pretend that you're mod 1.0 or whatever. And then these are saying something about like level of detail. So if you have your image and he's like really big, but you're putting him in like 4 pixels on the screen, you might want to have a like downsampled representation of that thing so that you don't have to do as much like CPU GPU transfer or something like that. Not particularly sure about that. But we can say, hey, do all those things and then return the texture, and then we won't upload the image to it yet. We will decide later to do that. And so we can in our main loop here attach the texture or like upload our image data to the texture, and then here we just call make texture. And these are image, not image. No vowels. And maybe we'll just get like this like uber fast version. Instead, we see that we failed. Error splitting the input into null units, invalid null unit size. Failed to send packet to decoder. Okay, so we've just clearly done something wrong. Something wrong. It would be interesting to know if this is the first iteration or not, or like the second iteration. So maybe we can do something like, we'll just print how many iterations we've done. So we'll say step this, and we'll print I, which doesn't exist yet, but we'll just say var I is a use size, which equals 0, and then we'll, at every loop, defer I plus equals 1. Boom. Okay, so it is immediately here. So error splitting the input into null units, null unit size. So it looks like this is just like unit size of negative 56. What is this? 1, 2, 3, 4, 5, 6, 7, 8, 9. 500 million is not a reasonable size. I also like that they're saying that, well, I guess they could be saying that this is not bigger than 393, but it would be funny if they thought that this was bigger than 393. That would be kind of a little fun goof on their part. We might just not be error checking something. So here we're saying, hey, I would like to read this frame into this packet. And theoretically, if we're error checking right, we should say failed to read frame here, which is not what's happening. We are failing at this. So we can like just look up the docs again and look at ffmpeg demux decode example. I think this is where we were copy pasting from yesterday. I think. And we can look at what they do. So in their main loop, while they read a frame, so that's here, while this is greater than or equal to 0, which is essentially the same as us saying if it's less than 0, return, we have gotten greater than or equal to 0. Check if the packet belongs to the stream that we were interested in. That's important. We need to check that, which we do here. And then this goes into packet. So if the packet, okay, so here. So we'll say, we'll start just saying stood debug print. Let's look at the packet. So we have packet is self, or let's look at the stream index. So this is going to be D, because that's what they're checking in the example. And we'll look at self packet stream index. There's also a good chance that I'm never like freeing this packet or anything, and I don't know if I need to like reset it between reads. But let's just see what this guy does. So he says, hey, we got stream index 0 and stream index 1, and then he immediately fucks up because we're feeding the stream index to an inches. Okay, so I bet you what's happening. I bet you what's happening is stream index 1 is probably audio. And we're probably saying, hey, the video stream is stream 0, but as we move forward, we go, oh, we got a packet for stream 1 now. We try to like feed an audio packet that we got into a decoder that's like just decoded a video frame. And he's like, what the fuck is that? So we have to do something here like if self packet stream index is not equal to 0. I think that we're hard coding stream index 0 here. Where do we, if number of streams is less than 1, maybe what we should do here is we should put it as a constant. Just so that when we're in the future, when we inevitably start handling this correctly, we can look for the usage of this variable, and then we don't have to worry about it anymore. Like, we don't have to worry about missing this. So here we'll just say return, and I guess we'll return null. Well, if this, let's say that the expectation of this API is that we get an image out, what we can do is we can just stick this in a loop. Right? All of this stuff can go in a loop. And in this case, we'll just continue. Yeah. And we'll see if that fixes our problem. Oh, hell yeah. Look at that. That's Big Buck Bunny if I've ever seen it. Look at that. Look at that. And what would be interesting is, I would like to see if we're like not cleaning things up correctly. So right now I have this like little hack in here where if I pass in -- lint, the application like exits cleanly after one frame. What we can do here is we can say if we were in linter mode and I is greater than 20, right? So we'll let it go through 20 frames, then we'll close, and then I should be able to run this with Valgrind. And we can see if we're doing anything like fucking stupid with our libav memory. So this is going to change to Big Buck Bunny. And if I run our little... Actually, probably what's easier, what I should do is I should comment out this check here. Okay. So this is going to take like fucking forever because Valgrind is like spinning up a virtual machine that checks all memory writes and like keeps track of them and writes them down and goes like, oh, this guy shouldn't have done that over here, but he did do it over here. Okay, sick. So we are seeing some bullshit. So when what is this saying? He's saying, hey, we didn't free some stuff. And is this like around 20 frames of it? Not a lot. It's just ff read packet, read frame internal, av read frame. So it's possible that we have to free something that we're not doing. Probably the frame, like it might require cleanup. Let's look at their example here. Yeah, they do unref the packet here. Do they unref the frame as well every iteration? No. This is within one loop. So I guess what these packets are like shared pointers to something. And these decode packets, maybe do they have like the frame? Do they have to unref the frame as well? Where is this decode packet here? Yeah, they do. So probably what makes sense for us is we have like one frame and one packet, and then we're handing out the data after. Lovely FFmpeg docs consist of examples and only examples that are undocumented and use at least one old API. I mean, I don't know. I think that there probably are docs. I just don't read them because I'm a fucking idiot. I like guessing and checking is like my mode of operation for almost everything. I noticed myself doing this in conversations too, where I'll like guess what I think someone's gonna say, and then I'll just zone out, and then like hope I got it right, and then I'll zone back in and be like, hope I got it right, like, or I'll guess what they're gonna say, and then like double check that it's the same as what I thought. And it's like, what a stupid way to behave in like the world. Like I could just listen to what people say and read what's given to me, but instead I just like same with books. Yeah, I found myself like skipping around a lot and then like being like, okay, so I think that this paragraph is probably going to say that, and then I skip to the next paragraph, and if it's like congruent with what I guessed, then I just like don't have to go back. But if it's like congruent and I was wrong, then I just have this like bad mental model of whatever the fuck I'm reading. It's like, oh my god, man, chill the fuck out, just read. Okay, so let's say that since we're just like handing out memory to this stuff, probably before we read the next frame, we can do like AV frame, AV packet unref here at the beginning of the loop. Maybe. And then here, maybe we do we have to do an AV frame unref? Maybe we do the frame unref here. Let's see if that like still works at all. Okay, that's a good sign. Nothing is like screaming at us. If we run this under Valgrind, is it doing the right thing? We'll give him a sec. He's got to think. Dude, what an atrocious frame rate. Yeah, okay. There, that fixes our leaks, which is fine. Yeah, I think we're chilling. I don't see anything sketchy here. Okay. Cool. Cool. Well, let's get rid of that step debug print. Fuck off. And, is that get diff? I think that's probably it for sequential playback. Oh, I guess, we probably should handle, when we get a frame, we need to, like, make sure that it doesn't just, like, slam, like, rapid fire, right? Like, when we're doing zig build here, this is just playing as fast as it can. Probably if we look at, like, the CPU right now, it's probably just, like, max the fuck out. Oh, maybe not. Why not? I would expect this to just be maxed out. It could be that, like, GPU... Oh, because, it's running at the frame rate of GLFW. Right, because we have, set interval? GLFW... interval? Yeah, here. If I uncomment this, then it'll probably just go rapid fire. I think that was saying, like, hey, could we only go once per frame? No, it's still... I don't actually know. What if I set this to 0? Maybe maybe it defaults to... Oh, there it is. Here we go. Hell yeah. Okay. Yeah, okay. So we need to limit how often we're willing to get a frame. And the question now becomes, whose responsibility is that? I don't really know. Like, somebody should block somewhere. And they should be blocking based off of timestamp of the frame. The frame will say, hey, I expect to be played at this time, and you played the last frame at this time, so, like, hold up for a second. And so I think it probably makes sense for our video decoder object being able to pump out frames as fast as fucking possible. That makes a lot of sense to me. So whoever is requesting the frames for him should be checking if he should play it. So maybe what we do is we will stash the last updated time here somewhere. Oh, I guess maybe we don't even... Oh, yeah, we do have to stash it. So, well, what is our timestamp thing? So first of all, our image doesn't have this, and calling it an image is maybe the wrong abstraction. So maybe let's change this to a frame. And maybe we'll even call it a video frame, because there are audio frames. Big Buck Bunny Nightcore, dude, that's so funny. I was just thinking, I have an extension in the browser that I use, because videos don't play fast enough for me sometimes. And, like, sometimes I like to crank them up at 4x, just so that I really can't tell what the fuck is going on, right? Just, like, if I'm, like, watching something that confuses me, why not just, like, really amp it up? And so it felt a little bit like that. I also realized that when I first heard Nightcore, I was like, this is sick. Like, what the fuck? This is crazy. And I realized it's because I've been watching so much fucking 2x YouTube that, like, I just expect music to be faster. Isn't that fucking stupid? Like, it's like, I've just ruined my brain. I'll bet you my, like, comedy timing is all off as well, because I just expect every joke to happen a little bit faster. Like, what a disaster. What a disaster. Okay. So this guy's going to store a timestamp, and he's going to get it from the FFmpeg frame. So probably it's in one of these guys. So maybe in the frame. Packet position, packet duration. I'm used to seeing, like, here, PTS. This is what we're looking for. Yeah. So, and then the PTS is probably in some, like, funny unit. I think I remember seeing that it's in, like, 1/9000th of a second or something. FFmpeg PTS, or maybe it'll be in the doc somewhere. PTS, or this will be AV frame. That's probably where this will be documented. PTS in time base units. What is a time base unit? Time base. Oh, time base. An AV rational. Time base for timestamps in this frame. In this frame. In this frame. I would hope to fucking God that your fucking time base isn't changing between frames. You would have to be such a degenerate to make a fucking video like that and expect somebody else to play it, right? Like, in the future, this field may be set on frames output by decoders or filters, but its value will be default ignored on input to encoders or filters. So I don't know if you're saying like, hey, I was at, hold on. So I have like PTS like 50 over here in time base. What's an AV rational? This is numerator over denominator. Okay, so we're gonna say like we've gone through like 51/10 seconds. So 5. Then I guess if you end up at 61/12 seconds, I would assume that this means that you have to wait. Like this is also 5. And no time has passed. This is what I would assume here. 60/12 is 5, right? I'm not like fucking stupid. 5 times 2 is 10. Yeah, okay. Whew. Was worried for a second. So probably, I guess maybe it's fine. Maybe you're not as degenerate as I thought you were. Because I was thinking like, what if, yeah, I would just assuming something else. Okay, sure. So I guess what do we store here? I think for us, I think the reason they store it this way is because you want to be able to create like fast hardware decoders, right? You don't want to stick floats anywhere if you don't have to because they're fucking slow compared to ints. But we can just say, fuck it. I don't care. I guess also your how do I want to say this? Your like precision might get really fucked up as well if your timestamps are moving really, really slow or really, really fast. But I think for now, we just won't worry about it. So we need to set the PTS. And this is going to be the frame PTS times. Also because floating error. Yeah, let's go. I think I tried to say that, but I might not have said it very effectively. So I think we just take the frame timestamp, we multiply it by the time-based numerator and divide it by the time-based denominator. We say this is an F32, and then everywhere here fuck, this is gonna be pain in the ass. Because of zig casting rules. So we'll do this. Float from int on the first thing. And then we will do a times equals here and a divide equals here, and then all of the float from ints should be able to figure out their types automatically, and I don't have to worry about doing all this like as F32 things everywhere. Okay. Cool. And so now in our like main loop, we can say, hey, the last PTS we got is negative std math float max. Well, I was going to say that we start at negative infinity, but maybe we want to set our like initial time. Yeah, let's do that. So we'll say start time is going to be some sort of like nanosecond timestamp that must come from the Zig standard library. Probably like, hopefully the Zig standard library has some sort of monotonic clock grabber from the kernel, and we can use that. Side note, dude, I'm pretty sure I've looked at the libc monotonic clock thing, and I'm pretty fucking what am I thinking of? I know that there are monotonic clocks that I've used that are not monotonic. I'm trying to think about what the context for that was. I think it was, I was looking at the GCC implementation for C++ clocks. monotonic, steady clock. I remember digging into some GCC code at some point and seeing that this was not monotonic, and when you went back in time, this got affected. That pissed me off so fucking much. I was so mad because we had this like bug in a camera that I was working on. I was working on like camera firmware where when you moved the clock backwards, a lot of our loops would just get like fucking stuck. Like if you just hit daylight savings, all of your threads would just not run for an hour, which is really fucking funny. And then we're like, what the fuck? We're using the steady clock. And it was just like, maybe it was like the implementation that we were using for like our ARM board or whatever, but it just wasn't monotonic. It pissed me off so much. So when I see these clock monotonics now, I'm like, is it actually though? I'm not sure. And I will just trust it though in this scenario and then get mad in the future when it bites me again. Okay, so I have stood time instant now. How long I've been coding? A long time by some metric, a short time by some others. I guess probably around like somewhere in the realm of 10 to 15 years. Dude, it's pissing me off. I'm getting old enough now where like 10 or 15 years is like the range that I can remember. I'm like, I don't know if I was coding when I was 15. Maybe. Like, I'm pretty sure that I was by the time I was 20, but like maybe not. I don't remember. Like, I know that I installed Linux really early because there was these... Oh, dude, this shit hits so fucking hard. I don't really care about your talking, but you could set up these like animations where you could trigger burning when you closed a window. Let's see if he hits here. Oh, it hits so hard. And then there were wobbly windows too. And I'm pretty sure that if Ubuntu didn't have, or not Ubuntu, like I guess it would have been Compiz, which was like a compositor that was used in GNOME. I think at the time maybe it was optional. I don't remember. But if it didn't have wobbly windows and burning windows, who knows if I'd be a programmer today, which is really funny. Like, because the only reason I installed Linux was because I saw it at my friend's house. I was like, that's sick. And then you install Linux and nothing fucking works. No, this was pre-Unity for sure. I know it was before Unity. This is Unity on the screen. But when I was looking at it, it was pre-Unity. Dude, stuff like this too. This like little fishbowl effect. Or like I don't really care. I don't want to see your like, oh yeah, this stuff hits so hard. These like, just like, why don't we have this anymore? Like, this was so fucking cool. Maybe it's because it's useless. It's probably because it's useless. But you used to be able to put a fishbowl in the middle. Like, there's like a fishbowl. And there was just like this 3D rendering of like some fish flying around in your desktop all the time. It's like, why? Like, why would you ever do this? But also it was so fucking sick. And yeah, I just don't know. Maybe I would have never learned to program if I didn't want this. Or if Linux worked, which is also funny. If Linux was just like a functional, usable operating system, maybe I also wouldn't be that into it. Okay, so this is going to come from stood time instant now. I saw some guy in our Unix porn that made this 3D gnome thing. Pretty fucking cool. Dude, Unix porn. I forgot about that. Yeah, I used to be all over Reddit Unix porn. And everybody would post those screenshots and they would all be Arch Linux. It was so fucking cool. Okay. I'm getting distracted. We want to say, hey, we have the start time that we started playing video was here. And also we probably want to keep note of the first frame time. Well, we'll see. Maybe the first frame time is 0. I hope it's 0. That would make my life a lot easier. So let's print out the image PTS. And it is a number. At image PTS. Let's just kind of see what that looks like. Here we need to comment this out because Zig's going to be like, you didn't use this variable. Why the fuck is it there? That's annoying. Every single PTS is 0, so that's not good. Self frame PTS of the float 32. Can we comment out this stuff? Okay, so these are incrementing in ones, which is confusing to me. My PTS is a float, right? It's a float. And what's our time base? Like, how is this turning into 0? Like, unless the numerator, like the denominator is like fucking tiny. Or massive, I mean. And the numerator is tiny. So we can maybe stood debug print the it's number over number and print self frame time base num self frame time base den. And I could use a debugger for this, and maybe I should have, because maybe that would have been a little faster. But it's too late now. 0 over 1. 0? 0? What the fuck? Time base. Is AV rational just doing something like fucking stupid, like numerator minus like +1 or something? Numerator, denominator. Okay. So if my time base is 0, then how could I ever have a reasonable PTS? In the future, this field may be set on frames output by decoders or fields, but its value will be default ignored on input to decoders or filters. In the future. So do you think that maybe it's not set on every frame, and I'm supposed to pull it out of like the stream initialization parameters? Could be. AV codec context time base could just be broken for that decoder. This is the fundamental unit of time in seconds, in which term frame times for fixed FPS time for it. Yeah, okay, so encoding must be set by user decoding unused. Okay, so in the codec context is also unused. So where the fuck is it supposed to be used? Time base, like output audio frame. Okay, what about wait, what the fuck? In decoder, it's definitely being used right now. Like, hello? Right? This guy is very fucking clearly outputting audio frame using the time base, and then here, he's saying that it's unused in decoding. He's a fucking lying bitch, this guy. Oh my lord. Okay, let's look at the context. And we'll just use this time base instead. Is it still here? Yeah, alright. That's still 0 over 1. Who? Let's look at FFplay. And surely they are playing back stuff at a reasonable rate, and we could maybe cheat and look what they're doing. Any advice for your programmer starting out? I would say just write code. Like, which is like a real, like, somewhat of a not helpful answer, but like, I would like don't get too caught up in like the right way of doing things, I think, and like you'll discover the wrong way of doing things pretty fucking quickly. Yeah, I think like I think that programming for the sake of programming, I've always found it difficult. But finding something that you're interested in drives the learning automatically. But some like, you know, so sometimes it's hard to like think of what is important to you, and if you have a project that you don't have a project that you want to do, then I don't know, to me, like, that's not a problem that I run into, because I just walk around the world and everything's so fucking broken or confusing. Like, I'm always like, why is that like that? Why did they do that? Why is this? How come when I go onto Google Maps and I fucking try to plan a bus route from here to downtown, and I like can get there really fucking fast on the train, but it takes me 10 minutes to walk to the train, then Google Maps goes like, well, you must want to take a 2-hour bus ride, and it's like, what the fuck are you talking about? Why are you doing that? Fuck, you know. So I just think like just all software, I feel like it's broken, it pisses me off, and so I always have something that I want to look at. But yeah, I think definitely just do stuff for sure. Okay, so someone in here must be using PTS. That's what we're looking at, right? Next TPS, PTS time base. Nice. Where's this coming from? So this is coming from... Oh! Okay. AV, no PTS value. That seems promising. And where do they must initialize it from somewhere before. Whoa, what is DTS? Is PTS for audio and DTS for video? DTS. Like, what the fuck? Oh no, we're seeing the PTS moving, so we shouldn't... This is the presentation time of this AV frame without PTS values. What is DTS? Decompression timestamp. Oh, okay, I don't give a shit about this. Sure. The time at which the packet is decompressed. Yeah, I don't care. I don't care. So they must be doing something like only decompressing it at certain times. Frame best effort timestamp. Like, what the fuck is going on here? What is best effort timestamp? Frame timestamp estimated for using various heuristics. Oh, so maybe in video decoders, it's not like guaranteed that you should know. That's kind of funny. Interesting. Best effort timestamp FFmpeg. Like, what is this? Oh. So I guess they're saying, like, sometimes you might not know. Start time, real time? What is this? In real world time. Okay, in epoch microseconds. Okay. AV stream time-based units, this guy's saying. So we can take a look at this. So we can look at the... Do we have stream cache in here? Hopefully. No field name stream. We must have like ditched it because we didn't think we needed it. So let's maybe... Oh, it's because it's in the format context. Format context stream... No. Decoder context? Maybe it's in? Where are streams? Stream index. This is from the format context. Yeah, okay. So here you can say format context streams stream index time. Oh my god. We'll just try to print out the whole thing maybe and see what happens there. What's in streams stream index? Great. He doesn't tell us. I didn't want to know anyways. Time base. Yeah, okay. Then we yank this shit and paste it again and write den here, and then here we can go back to printing D over D. AV stream does not support field access because it's a C pointer, so C pointers have to be manually dereferenced. Okay. Okay, so here we have a frame rate, which is good. I don't really understand this best effort timestamp still. Like, why does it exist? Do you think that neural networks will tell us? Why does FFmpeg have PTS and best effort timestamp? Optional field, more accurate when PTS value is unavailable or unreliable. Okay, whatever. We have it, so we'll use it. I don't really know why you would ever not know when you want to display a frame. That's confusing to me. Okay, so here, just instead of using the frame time, since it's unreliable, we'll say stream is this, and then we can just say, or maybe we even just pull out time base here. We'll say time base like this, and delete these things, and then we should be telling. Cannot assign to constant, so this will be a variable. And now we have a thing that's changing in seconds, which feels good to me. And then we just say, hey, oh, start time. Well, I don't know what start time real time here is either. What is this? Like, is it saying when we, does he know when we checked the first frame? Start time real time. Like, I could see a world where this gets initialized after we decode the very first frame. The stream was captured at this real world time. I don't know if this means that it was captured, like, in the video, like, at the time of recording or at the time of playback. Set by the caller, AV right header. Surely this is at recording time. In which case, I don't give a fuck. Instead, I keep track of my own start time. And this, I guess, is constant. And just every frame, we only update the image if something. I guess we have a variable image here. Like this. And we can say const now is equal to current time. Oops, I fucked up my yank. I'll just retype it, I guess. Fine. Like a fucking peasant, I will use my fingers, work the fields. And if image.pts is greater than now minus start time, I guess we'll do even a while. While this is true, we will upload the image to the GPU and then say image is equal to try image or decoder next, which is a little bit wasteful. A little bit because how do I say this? Like, we don't really have to upload to the GPU every single one of these, but also I think that this kind of gets like lazily evaluated by OpenGL, and it might actually figure out that it doesn't fucking matter. Is this how video editors like Premiere work, rendering to OpenGL textures? No fucking idea. Instead of doing research and looking at state of the art, what if instead we just did the first thing that we thought of, right? Then you could end up with a way shittier product. Isn't that great? Okay, so this subtraction isn't working because this instant is some fancy type, which is a POSIX time spec, I guess. So is there a way to like, okay, you can ask for a nanosecond since. Perfect. So we can say, which way does it go? This is the earlier is the second parameter. So start now since start time, and this is in nanoseconds. So here we need to multiply this by. Do we have 1E9 syntax in here to go from seconds to nanoseconds or nanoseconds to seconds? Oh, this is actually divide by. And we need to turn this into a float first. So I guess instead we'll do int from, we will multiply this by 1E9. There we go. And then here we say float from int. And I guess we will as float 32. Oops, wrong button. All right. Perfect. It worked. We never hit this, I guess. While image PTS, oh, is this supposed to be less than? Probably why. Okay. Do you think that that's playing at the right speed? It could be. It could be. Where are we? We are in work, video editor, Big Book Bunny. Yeah. Yeah, that's pretty slow. That pan down. Yeah, okay. I think that's right. I think that's right. So I think that we can consider this done. Decoding sequential frames with FFmpeg. And what did it require again? So we fixed... what did we do? We fixed some frame unreffing here to make sure that next frames were cleaned up. We stuck the timestamp in the image output, and then we just checked the timestamp, and then in a loop, apply the next frame if the timestamp matched. Cool. Cool. Okay, let's try to get some fucking color in there. Get some color in there. And probably we're going to do whip, and we're going to add -u, and we're going to hit -m. We'll just say frames moving and grooving, and I will fix that later, as always. I guess also something that we're gonna have to do at some point is fix stride not equal to width. So we have this like black bar on the right side, and this is just because the stride doesn't match the width. We're also going to have to fix aspect ratio, and we also have to make it so that the image takes up full FOV. We're gonna have to fix all these things. But we don't have to do that yet. I want to do color first. So what I'm thinking is probably it makes sense for our frame abstraction to say what the data type is. Or maybe we just hard code YUV 420p. I like that better because then we don't have to do any work. So here's what we'll do. We'll say expected frame type. And maybe we'll do this down in our decoder. We'll just take this thing that was previously saying, hey, if it's RGBA, if it's not RGBA, we don't support it. And we'll just change this to if it's not YUV 420p. And then we can just make assumptions about it everywhere. Yeah, sure. Okay, so in our loading of our texture, we just multiply our height by 1.5. So 3 over 2, right? Because we should have two luma pixels, 4 luma pixels for every 2 chroma pixels in YUV 420. And when we upload this thing, now if we run this, what we should see is like some fucked shit down here. Perfect. Do I think that makes sense? I was kind of hoping to see the same picture. Where I was kind of hoping to see like low res versions of this, but maybe that's just not how the memory layer works. It's also possible that the chroma channels are maybe not in this buffer. It'd be interesting to see, because I remember seeing that there were multiple planes of data in the frame. So maybe this is just Y data, and we have UV. So let's look at the self frame. There's something in here like data here has like 8 possible things in it. Is NB samples what I want? Let's look. I've never seen syntax of Zig. Looks very easy if you ever code in C or C++. I would say that Zig is just like, it's just easier C in my mind. It just does what you want C to do, and it does it sane, and it feels good. But of course, with some downsides of not being around for 50 years yet. C's got a lot of momentum. What am I looking at? I'm looking for frame. AV frame. What the fuck is this search box doing that takes so fucking long? Like, surely it shouldn't take like 3 seconds to figure out if AV frame is in the index, right? Number of samples per channel. So this isn't what I want. I want to know if like data 2 is like allowed. I want to know if my data has UV in separate planes here. All pointers and data extended data must point to something. Nothing in here says how to know if it's valid or not. It could be if line size is 0. For video, a positive or negative value, which is typically indicating the size and bytes of each picture line. But it can also be negative byte size of lines for vertical flipping, positive, negative, multiple of byte size. AV frame data is an array of 8 pointers to 8 planes. But, like, how do I know if I'm allowed to use those planes? Right? Do I just have to know that on YUV 420, 0, 1, and 2 are set? I kind of assume that someone here would tell me, like, number of planes that are allowed. Oh, check for null. That's not a bad idea. Yeah. I didn't catch. I see. Could be. All pointers in data extended must point to one of this. Okay, yeah, so let's just see if they're nulled out. We could look at self frame data. We say 4, 0 to 8. Actually, we should just, you know what, fuck it. At this point, it makes sense to GDB args zig out input big buck bunny, and we just break one here, and we see what happens. Run. P self frame. What's in here? What is in here? Okay, so we do see zeros for line sizes, which is really good. And we also see that the line sizes are half the width on the second and third channel. So the fact that this is almost certainly U and V. Almost certainly. Then our data self frame data. Why is it looking like this? Repeats 160 times? Like, what is going on here? Oh, I see. This is just being fucking stupid. GDB saying, like, hey, there's a pointer to this memory address, and in that memory address, we see a black screen. And then in here, we see color. Okay. And then, yeah, we're seeing null pointers here, too. So we can check both, but... Which means that here, maybe our video frame is just going to be Y, CB... we'll use the words U and V. I think they're interchangeable. And we're gonna have to slice it according to what we see here, so. Okay, so this is Y. And I guess our stride is going to be in like some odd unit here. Because the stride is going to have to be halved for U and V. So maybe we call this Y stride. I guess maybe these guys need to be another type. Const, like, I don't even know what to call it. YV plane or something. And here we'll say our stride is some value. Our width is something. No, we can derive this. Okay, we'll leave one stride and we'll figure it out from there. We'll get crazy with it. Okay. So here what we want to do is we want to assert that the U and V strides are half the Y stride, just to make sure. So we'll say line size 1. If this is not equal to self-frame line size 0/2, then we say return video decoder error unimplemented, and we'll say stood log error assumed assumption that UV channel stride is half Y stride is not true. Sure. And we'll do this for I guess we just do an OR here. Like this. Yeah. Okay. And then here we assign Y to Y. And U to U and V to V. And then this comes after. And U and V come from 1 and 2, but these are going to be stride over 2. Boom. Boom, 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 boom. Height over 2 as well, actually, right? I think. Because it's downsampled in both directions. I think so. Which I guess is the same as doing y.len/4. Which I guess is like a little cleaner. By some definition of cleaner. No field name data. So everywhere we're using data before, this guy needs to turn into y. And then he doesn't like division between cint and comptime int. Oh, that's interesting. That's super sick. What a good error. I like that a lot. So just making me choose the behavior. What's the difference between div trunk and div floor? I guess maybe one of those turns it into a float and one of them turns it into an int. How fucking cool is that? How fucking cool. Where is documentation? Here. So what is div floor? Floor division rounds towards negative infinity, but for unsigned integers, it is the same as numerator over denominator. Okay, what's the difference between that and div trunk? Rounds towards 0. Yes. I forgot. There are sometimes bugs in this. I think I saw at one point like a Mario 64 exploit depends on this behavior. Can't remember. I've definitely seen this come up. Okay, so we'll just pick one. It doesn't fucking matter. So here we use div. I like a div exact. I assume div exact gets angry if. So does this result in unchecked or checked undefined behavior? Caller guarantees that denominator is not equal to 0, and div trunk this is equal to that. So for a function that returns a possible error code, use this. But then why? What does this do? I guess probably this just. Like, wouldn't this and div trunk just be the exact same implementation on the hood? Can we look at what branch I have checked out here? Get checkout 012. Oh, do I have it? Get pull. I just want to know. I want to know. Can you show me? Can I look for like div exact in here? I guess it's compiler built in? Do they have like built in? Nice. Oh, this is a different built in. Div exact. Maybe we look for string of div exact. No. I just want to know where, like, cogen? No. Fuck. Oh, here we go. Function div exact. This is an arm, though. Function div exact. No. Is there somewhere where... Oh, here we go. It's an enum. So we can look in here for the macro, for the enum value div exact. And okay, so what is going on here? Gen body. Who knows what this does? But it does seem like div floor, div trunk, and div exact all map to... Oh, div exact optimized? Div floor optimized? No. Okay, it's not as trivial to get to where I want it from here. But I'm confused about the difference. But I don't think I'm going to figure it out quick enough for it to be worth looking there. But I really don't understand. I just don't understand. Denominator not equals 0 might allow us for something as well. I guess we could look at the standard library div exact and see why it's checking. Maybe that'll be easy to figure out. He's probably just going to check and then run div trunk. Oh no, he just runs div trunk. Yeah, okay, I don't understand. But what we'll do is we'll write stud math div exact here. Fuck it. Div trunk. It's fine. If we're off by 1, get fucked. Like this. Like this. Okay. And then we do it here as well. I'm definitely going to be looking into that div exact thing after stream, but we just can't get too sidetracked. There. Okay. Zig build. Wrong folder. Zig build. Chillin'. And okay, so we have our YUV planes. And so I guess now we need to expect 3 textures. Yeah. So we will sample from Y. And we will call this Y, and we'll, for now, just write Y here. Well, for now, let's just do something really fucked up and write U and V in here. Just because I want to know. But these should not be from the frag chord. These should be from frag chord over 2 on both of these. In both directions. So I think that's fine. And we'll figure it out later. But we should see now that we get, like, maybe color that kind of follows the right shape in G and B, but not necessarily the right thing. Right? We should see color boundaries that match the world, is kind of what I expect to see there. And so where do we activate our texture? Here we go. So here. So what we're going to do is we're going to make 3 textures. So we're going to call this Y texture, U texture. Yes, it's all coming together, and V texture. And we'll just have to bind them in the right order. So here we say, hey, texture 0's chill, texture 1 is chill, and texture 2 is also chill. And then here, we just have to bind the appropriate texture, which we weren't doing before, which is fucked. So here we bind Y, upload him, bind U, and do this like div trunk stride 2. This image height should just be image height on this one, and this should be div trunk image height 2, like this. And we just do the same thing for V as well. This is the wrong pointer. This is U. And this is V texture and V. And maybe that's it. Who knows? Zig build and run our shit. Oh, I'm in the wrong fucking folder. That's kind of funny. I just ended up back in the QR decoder. Input big Bugs Bunny. Let's see what happens. Absolutely fucked. Because texture, no matching function to texture float vec2. So what did I fuck up here? Oh, because I rebound Y over this. So we'll call these we'll underscore these with text. So this is Y text, and I also sampled from the wrong thing here. All right, let's try that. Okay, so we are seeing okay, there's some fucky wucky shit going on here. For sure. So the red is the Luma channel. We are definitely seeing something too big on some of these guys. So what's going on there? Apparently div exact will error if there's a remainder. But it doesn't say that. Am I high? It just says that caller guarantees. But you're saying it will panic. I guess we could always just test that. Oh, so maybe there is like what is it called? Checked undefined behavior, and it just doesn't notice that. It just doesn't note that. That would make sense. Check undefined behavior would be nice. That's what I would want, but it's fine. It's fine. Also, sorry, I didn't notice that you said that a while ago, so. Okay, let's double check here. So we have our stride and height here are divided by 2, which I think makes sense. And then in our shader here, we are taking the frag chord over 2 as well. So let's just double check. Let's look at the Y channel only. So this is like we expect. Then we can look at the U channel only. So here it's clearly... what does the actual picture look like? What the fuck? So, okay, let's look at this again. Oh no, okay, we are kind of funky cropped here. We're seeing only like this stuff or something. Okay, so that kind of makes sense to some extent. So my frag chord here is where percentage into the image that I am. Oh, we can use the frag chord directly because we've bound the textures at half resolution. Yes. Okay, so I was double accounting for the half width, half height. Once when binding the texture and once when mapping the texture. Because in image space, this is like, you know, whatever, 480 by 320 or whatever. Like, doesn't fucking matter, right? Like, whatever this resolution is. When we bind this, these get mapped in OpenGL world to 0 to 1. 0 to 1. And we were correctly mapping this to 0 to 1. But then when we were trying to say, okay, we have this square in our picture, we also map this 0 to 1, 0 to 1. And so we were dividing by 2 in both of these cases, which was causing the problem. Okay, so let's go back to our YUV test. we should get like hella fucked up colors. Maybe they're not that fucked up. Maybe we just don't see them at all. Surprising, to be honest. Yeah, why? I would expect it not to be fully black and white there. But whatever. Maybe let's try doing the math to convert between the two and see if that gets us something sane. So this is y prime times 1 u and v here. So what is y prime here? Y prime is probably some sort of like offset weighted thing. I wonder if we're at BT709 or BT470. Are these numbers different? 1.13. Yeah, these are just different numbers. Those are just kind of cool. Super cool. How do I know? How do I know the mapping? Interesting. Interesting. This is confusing. How do I know the color space? Maybe FFmpeg will tell me. So where am I getting the pixel format from? Self-frame format. So maybe AV frame. Does he have anything that can give us a clue about the color space? Format. I mean, also, like, it seems kind of like, to me, that AV pixel format should be the one who tells us. Indian, blah, 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 blah. So what I want to know is the color mapping. Color mapping, color mapping. We could also look for if there are, like, fucked up YUV. So what is this, like, P, B, blah, blah. Oh, somebody's got a link for me? Nice. Get pix format name. Yeah, this will tell me, like, the pixel format name. But I want to know, like, if the which YUV we're looking at. You know? Can we just maybe, like, FFmpeg BT709? Somebody will have looked this over. Colorspace. Okay, what is Colorspace? Why should we care? Well, I want to care because surely this is self-explanatory, right? Why should we care? Because we want to see the fucking colors. Okay, difference between RGB YUV, blah, 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 blah. Note YUV is ambiguous and often used wrongly. I'll bet you I'm contributing to this a lot. Okay. YCBCR is more accurate. Y prime UV, on the other hand, specifies the color space of luminance and... Okay. So there's no practical difference between YUV and YCBCR. Sort of more like RGB and BGR. Okay. UV doesn't explicitly state the exact color difference. So it might be CBCR. And the following, YV is used in FFmpeg pixel formats referring to YCBCR in digital video. The conversion between buffer representation and visual representation depends on the type of YV represented in pixel buffers, which are essentially device dependent. Oh, no fucking way. So it depends on the resolution of my fucking frame? It was under the big table in the docs. Was it? Under the big table. Ooh. Ooh. Very good eye. Nice. So, AV color primitives. Chromatically coordinates of the source primitive. And so do we have BT709 is like one of the things in here, right? Yeah, sick. Okay, so now how do we find this in the frame? Surely this is in the frame, right? So what was this type called? AV color space. Oh. Boom. Okay, perfect. Okay, this is what I was looking for. This is what I was looking for. Color space, baby. So let's just check the color space and then assert it. So we'll say self-frame color space is not equal to AV AV call, of course. Of course. AV call What do we expect it to be? What do you think the difference between SPC and PRI are? Oh, SPC is space. Okay, so let's assume BT709 at first, and then if it's different, we'll fix it. So here we're just going to say, there's get pix format name. Is there get color space? Is there color space names? We'll just log the number, I guess, for now. It would be nice. AV color space name FFmpeg. It'd be nice if we could like print it like a word, like I want to use with my brain, you know? Plain text. This is not what I expected when I clicked plain text. I was kind of hoping that it would tell us what it is in plain text, not like a, you know. FFmpeg color space enum to string. Surely they have this, right? Pix desk. Color space. AV color space name. Hell yeah. There we go. Okay. And so let's just run this, and if he works, we're telling you. Unsupported frame format unknown. I typed the wrong log. But saying unsupported color space unknown is very frustrating. Very frustrating. Maybe this is one of those things that's only set sometimes. Like, maybe it's not set per frame, but maybe the color space is set per stream. Maybe. AV format. What's the fucking type? Oh, I'm gonna lose my fucking mind. I'm gonna blow it. I'm gonna blow a, what's it called? When you pop and the bolts pop, blow a gasket? What is a gasket? So this is, this is like the blow a gasket. So this is probably like when steam leaks out of like something that's supposed to be airtight. Like when your ears steam, it's the same as blowing a gasket. Maybe? Nah, doesn't fucking matter. Who fucking cares? Pop a vein, blow a gasket. Alright. What was I actually trying to do? I was trying to figure out what the type of AV format context is. Because we wanted to know the color space. It feels like such a simple question. Like, oh my god, I almost lost it. Okay. So in here we have streams, and the stream will maybe tell us the color space. No. No, of course not. Oh, I think I've seen somewhere that you might have to load stuff sometimes. Like, maybe the implementation of color space name doesn't work until you call some other fucking function. AV color space name. Maybe AV color space name. So we return color space names. No, that's just like a fucking hard-coded table. So yeah, I don't see any reason for that not to work. So it just must be that we're not one of these. But why? Why? I need to know. I need to know the color space. Unsupported color space 2. Unspecified. Why? Why? How am I supposed to know? Unspecified? FFmpeg YV color space unspecified. Well, what does ffplay do? Set YV conversion mode. So if automatic. Are you supposed to just fucking, like, look at it and guess? No fucking way, right? Because what's happening here is that, like, they say, hey, SDL, you fucking figure it out. But maybe we know, and so if we know and we see that it's 709, then, like, yeah, definitely use 709. I'm guessing YUV 420p works with only one color space. It's possible, except here they're definitely saying that there could be multiple in here. What does this do? SDL YUV conversion automatic. Define an SDL surface. Automatic. How do we know? Surely somewhere in here. Is it, do we just clone SDL and then look? Is this how you're supposed to fucking write code? Like, I don't know a better way to find the information that we're looking for, but surely this is wrong, right? Like, surely this isn't what I'm supposed to be doing? Depth 1. I don't really care about anything except the most recent. SDL. And we can just look for, YV color, what was it? Conversion automatic. Okay. Bro, what the fuck? Okay, so the Wikipedia page did kind of hint at this, right? He did kind of say that SD and HD have different, but, like, bro, come on, man. So what's actually kind of funny here is that this actually means that the big buck bunny that we pulled is, we pulled the smallest version to start with, right? We pulled this, like, the 320 by 180 version, which actually means that if we test on this and then we upgraded and we didn't check this, we would just get the wrong colors for every video except this one. Oh my god. Okay, it's fine. I don't know who I'm really mad at, to be honest. I don't know if I'm mad at anyone. Like, I'm not being like, fuck you, FFmpeg. That's not how I feel about this. I guess I'm just kind of more angry at, like, the state of the world than anything else. Which is kind of funny. Okay, so actually we wanted to go back to SDL here because I wanted to know what the threshold was. It was 576. Okay. So what do we want to do here? There's two paths forwards. One is we could upgrade to HD video because everything I'm going to be working in is going to be HD video, or we could just try to implement it. Let's do the low res one, or we'll do the other color space, and then we'll figure it out later. Like, if we need to implement a different one, then we'll implement a different one. I usually just convert from YUV 420p to RGB on CPU and draw RGB. Sure, but, like, I guess you're kind of saying that, like, lib SW scale, like, handles this properly for us and we don't need to think about it. Yeah, that makes sense. I am a fan of understanding your data, though. Okay, so here, let's just say... No, I don't use that. But then what do you use? Right? Like, you need to be using something that is aware of this, or you're getting it wrong, right? And so it's like somewhere, something must be handling it. It's just a formula, but the formula is different depending on the function, depending on the height, right? That's what we're angry about, is that the frame comes in, he says, I'm YUV 420, but the formula for conversion depends on the resolution of the video, kind of. If it's unspecified, if the color space is unspecified. So here we will say that we are expecting, because we're working with a low res version, we are expecting the low res one. And I guess we'll just use the FFmpeg things here. So it's BT 470. We want 470 because it's SD. What's the difference between M and PG? Fuck. What's the difference between 470M and 470PG? Oh no. Oh no. Okay, so this is system M. Okay, let's just pretend it's system M. Well, what does SDL do? 601. That's not even the same thing. What the fuck is BT 601? That's not in here. This is 470. We need 601. Is 601 an option in this? No. Oh, here. Oh, 601 and 470 are both the same thing. Like, BT 601 here, BT 470 here. Oh, I'm gonna lose it. I'm gonna lose it. Where's 470M? Oh, this is color primitive. Oh, okay. Whoo. Okay, color space and color primitive is wrong. We want to look at color space. And we want whatever BT and we want BT 470. Okay. We're chilling. BT 470 is like kind of the same as 601 according to that link in the comment in SDL. So we'll just do this and we'll say if const color space is equal to if self frame color space is equal to C AV call space unspecified, then we do whatever the fuck they were doing in SDL. And will Zig automatically propagate this stuff? I think it will. Maybe I have to take the squiggle brackets out for this to work, but we will use C AV call space BT 470BG. Else BT 709. And this height comes from these guys here. So we'll kind of just slap this up here. So if height is less than the threshold, which was 576. Okay. Cool. And then here instead of self-frame color space, we look at color space. And then in this else branch here, we just use the color space. Self-frame color space. Okay. Boom. Value of this ignored. Fuck. Do I have to like... we'll just make it a function. We'll make it a function. Fine. We'll do it. We'll split out some code and make it easier to read. Why? Like, if you really want me to. Resolve color space YUV. And we take in a color space, which is a CAV color space. Yeah. And it returns a CAV color space. And, oops, I got an extra rec in here. And here we'll just put a comment and say, like, color conversion depends on the color space. Color space may be unspecified. If unspecified, we use heuristics to determine what the best fit would be. There. Good enough. And this just comes in here, and we do like bump, 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 bump. And this can be lowercase, I guess. I don't really need uppercase for cat constants. I can fucking figure it out. We will say maybe we do the not equals case first so we can return early. So this goes like this. Then this stuff doesn't have to be indented, which I like better. And then here we will just hit return here and here. Boom. And which means we just take in a height as well. And so here we're going to say our color space is resolve color space YUV for self frame color space and our height. Yeah. Simple. Simple, right? There was no problems in any of this. No part of this was confusing, and it was just simple. Don't worry about it. Okay, so now we know that we're in the 47DBG one, and we can just slap the formula in here. Oops, this guy doesn't like having self.frame everywhere, so do that. And we'll just go to our fragment shader now, and we can do the formula according to the low-res version, which is this one. So we have to calculate y prime first. So this is... I wish that this wasn't in like picture. I guess we will do this. Please use embed file for the shaders. Get fucked, I guess. We could, but I'm not going to yet. At some point, I probably will get fed up enough to do it. But for now, no. Okay. So, Y prime comes from RGB. But how do I... okay. But I don't have RGB. I only have U and V. And I only have Y. I guess maybe Y prime is just Y. We can kind of infer that by trying to see. So this is 299, 587, 114. 299, 587, 114. Yeah, okay. So this is just, maybe we just assume that we have Y prime. I don't know why they're putting a prime on it then, though. Because it does look like there's no Y without a prime on him. So yeah, I guess we'll just use him the way it is. And so then we just like unwrap this matrix multiplication. So float R is equal to Y plus 1.13983 times V. G is equal to Y minus 0.39465 times U plus minus 0.58060 times V. And B is Y plus 2.03211 times U. And I think that's it. Can't you just use a matrix? I could. Yeah. But I don't know why I really would. I guess maybe it's like slightly faster because GPU has instructions for it. Yeah, I guess it could parallelize further. I was kind of imagining that we're already massively parallelized because we're in a shader running per pixel. But you're probably right that the matrix multiplication would be faster. But also, I don't give a fuck. I think this is one of those cases where you're like, you're right, but I've already done the wrong thing. This is wrong. What the fuck? I remember seeing somewhere, like, that Y should not be 256 at first. The resulting ranges of Y, U, and V are 0 to 1. And are the inputs 0 to 1? They should be. For small values of y, it is possible to get RGB values that are negative. So in practice, we clamp the RGB results to the interval 0 to 1. Okay. What am I missing here? Y plus 1.13 times V. Oh, I could have y, U and V switch. That's possible. Let's just try seeing if that's possibly it. No, it is still just really fucking purple. And really fucking bright. I remember seeing something somewhere about, like, Y minus something. It's all using texture R. Yeah, that's intentional because it's one channel textures. Y, V, are blah blah weighted values of RGB, produce Y, a measure of overall brightness of luminance. Difference between Y, B, and R values. We're going to assume that we're using this and not whatever the fuck YIQ is. Oh, which we'll use later in BT601, although it uses 1/2 instead of 0.436 and 0.615. This... Okay, this looks more like what I feel like I've seen. I remember seeing these 128s. Okay. Do they have the inverse here? They do. So this is... Yeah, these are definitely not 1. 255 over 2... Yeah. This looks... So why does this look different than whatever the fuck this is? Right here, they're multiplying everything by, like, some scalars. But then they're kind of saying here that it's equivalent. Which is, like, they also said that in the Colorspace thing here. They said 470 BG is the same as BT601 blah 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 blah. So what the fuck? Right? What the fuck? What the fuck? I'm gonna lose my fucking mind. Is it possible that I did some wrong math here? I mean, it's always possible. I fuck up my math basically every time I do it. Okay, let's just sanity check again. Like, let's just look at Y, U, and V as separate planes here. There is something funny here where I feel like we're not seeing color. Yeah, I'm not convinced that we're getting the correct textures in here. Very much not convinced, actually. We can prove this by zeroing out the U and V before uploading them and just seeing if that fucks shit up. Is data mutable here? It is, yeah. So let's just fuck our shit up. Memset U 0 and memset V 0. Yeah, okay, so the fact that we're not seeing zeros here indicates that these are not being set right. Which means that this probably just isn't sufficient to bind the textures. I wonder if we have to do this here before uploading. I could maybe see that being relevant in some way. No. I mean, also, we're just not setting our uniforms, which is really just asking for problems. So let's go into our shader, and there's a way for us to set the location on here. GLSL set location. Set layout qualifier. Here we go. Yeah, this will tell us. So we'll just say layout location equals whatever for. Where's our uniforms? For uniforms, uniform layout qualifier GLSL. Is this what it's called? Layout binding equals this. Okay. So we should be able to say layout binding equals 0, like this. And here we set 1 and 2. And then here we should be able to say GL set uniform GL open GL bind texture to shader. I think it's something like learn OpenGL textures. Here we go. We shouldn't do, like, this is what we get for just skipping stuff. It's also how we learn, though, because if we didn't skip it and hit this, then in the future we wouldn't be as upset. But here he did just do this. But then here he did do this as well. So what the fuck does active texture do then? Active texture. Specifies which texture unit to make active. The number of texture units is implementation dependent, but must be at least 80. Texture must be one of GL texture I, where I ranges to 0 to blah, blah, blah. But, like, what is it? What's the difference between active and bound texture? What is the difference between active and uniform texture? He's gonna lie to me. Dude, the amount of times I ask this guy a question, he just fucking lies. But sometimes he gets it right. Like, even sometimes he just says something that, like, makes sense to me in human words, and then I go back and look it up after. Active is dynamic texture, blah, 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 uniform. Oh, I did ask the same, wrong thing. Well, refresh, who doesn't know I'm fucking stupid. What is the difference between an active and bound texture OpenGL? Active texture refers to a texture unit that is currently enabled and ready to be used for rendering slot. Yeah, okay. Bound texture is that is currently attached. You bind a texture object to texture 0. But then, like, why do I have to set a uniform for it? I don't. Oh, so it's probably. I think it's something probably like. Slots. We can have like 80 textures like activated. Then we have like textures. And these are like, we could have as many as we want. And then when we bind textures, it's like where we pick which one of these guys we're working on. Then when we set them, we kind of like push them into whichever slot goes in here. And then probably when we set uniforms, it's probably doing like we have like uniform 0, 1, and 2 for our different names. And these are probably have to get linked like this. Probably. That's my guess. GL active texture tells OpenGL, I want to talk about this texture unit in other commands that follow. But isn't that what, like, binding tells me that I want other commands that follow to work on this texture, right? So I'm confused about the difference between activation and binding a little bit. I'm not sure if this is right, but this is a mental model that could make sense. The lower links in that picture are one-to-one implicitly. Maybe. Yes. But then, like, what I kind of assumed that they were one-to-one initially and that I could just skip this step. But I think that's just not true. Let's see. So in learn OpenGL, they do in here, they call set, they look up the location of this guy and they set it to use. Oh yeah, they're just writing the texture slot in here. Yeah. So I should be able to say GL set uniform, GL uniform 1i, probably, to set the thing. GL uniform 1i to set the locations. We have our locations hard coded in the shader as 0, 1, and 2. So we should be able to say, hey, I want to set those 0 to 0, 1 to 1, and 2 to 2. And so here we're kind of like mapping between texture slots and the uniforms, I think. And then hopefully now we see nothing. Oh, no, because we just fucked up compilation. Can we go back to where this program started running? Unrecognized layout identifier binding. So this is how you do it. Uniform. I don't want to have to like look up the names because I'm too fucking lazy, but it turns out that this is actually probably going to end up being harder. But now I want to know. Set uniform location. USL. Explicit uniform location. Yeah, yes. I'll write location instead of binding. Still no bueno. Uniform requires, fine. We'll look up the fucking name. We'll do it right, and it'll be better. It'll be easier and better. But like, look. Okay, so this is GL get uniform location, which takes in some unit. What the GL get uniform location, which is the program. Okay, so we have our program, and we want the name of ytex. Oh, you know what we could actually probably do? I bet you. If that works, we can get fucking crazy. That doesn't work either. That's not a surprise, to be honest. That would have been too crazy. Okay. So set ytext to 0, set utext to 1, and set vtext to 2, and then we have to make sure that y, u, and v are lined up correctly here, and let's just see if that at least does something. Okay, now we're seeing a black for showing the u, because we mem said it's a black, so that's a really good sign. And now we can go back to trying to look at the u channel directly, which we are seeing like some semblance of Big Buck Bunny, which is really good sign, and it's fucked up looking like we would expect. And now let's go back to using the R, G, and B things we calculated here, and maybe they will look more reasonable now. No, they still they still look fucked up. And somebody at some point said that there needs to be 0.5 for offset for U and V, which I would believe. I would believe that. Let's just see what happens if I do that and see if it looks kind of sane. Oh, hell yeah. That does look sane. I don't know how sane. That looks really saturated, but maybe Big Buck Bunny looks really saturated. Where is that? Yeah, I mean, that looks like maybe right. Like, not so wrong. There could be, like, I wouldn't be shocked if I had made, like, minor mistakes in here, but definitely close enough. Right, in reality, close enough. Which is pretty sick. All right, so we spent a lot more time on color stuff than I would have thought, but we are somewhere, which is pretty cool. Let's at least actually, before we call it, let's just fix the size of this square because it's fucking stupid. That we're watching this like tiny fucking thing. just so that we can... Oh, man. Oh, man. I think in our fragment shader, we're dividing by 2 somewhere because... this is now plus 1 divided by 2. I think. There we go. Okay. Let's like kind of get the aspect ratio kind of right. Okay. So that's pretty exciting. I spent way longer on color stuff than I would have thought, but we also kind of went down a rabbit hole, which was kind of fun to explore. So I don't know. We can say that we're happy there. Yeah. So we're gonna call it there. If you like what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours. It's 4 o'clock now, so 2 hours ago to now if you're on Twitch. If you're on YouTube, you'll have to figure out what time Pacific time is for you. If you're new here, there's a YouTube link coming out of the rabbit hole now. That's so funny. Dude, I don't know if that was an intentional joke, but if it is, you're a fucking genius, because he is coming out of the rabbit hole. If you like what you saw and you're new here, there's a YouTube link and a GitHub link in the Twitch description where code for this stuff will eventually go up. And then on YouTube, this and previous projects are organized into like playlists. So if you want to see what else we've worked on, you'll see things like a Rust operating system, terminal emulator, diff tool visualizer, I don't know, neural network stuff. I don't know. There's a bunch of stuff. It trends towards whatever the fuck I feel like. QR code decoder. What the fuck I feel like is what's up there. Trends towards lower level, but we have fun. If you're watching on YouTube, there should be a Twitch link in the YouTube description. And I think that's all we got to plug. Goodbye, YouTube. I'll catch you guys later. And Twitch people, let's try to find someone to raid.